Okay, good morning. So I will introduce myself. I'm Patrick Grossetete. I'm working as product manager at Cisco. I've been the first product manager at Cisco covering IPv6 on iOS. And first, I would like to thank you for the invitation. And the second thing is I can demonstrate why V6 is working. I'm currently getting 2 V6 connections from my provider in Paris. And at least one of them is working since this is what I can see from the window of my house over there. So at least you have the connection with one of the provider, but it looks like one of the peering is not working with the other one.
Why does that look like the Bastille?
Yeah.
What is that?
So something interesting, when I started at Cisco, I used to work for Digital before working at Cisco, and I went through the DECnet OSI story. And when I took responsibility for V6, I said, oh, by the way, I don't want to talk about transition or migration. I already heard the story. So that's the reason the marketing message from Cisco is about integration and coexistence. And the reason is you will integrate IPv6 on your IPv4 network because your application, your business is still running on v4 today. And you will have to make v4 and v6 coexisting together. So now the problem is, if I look at the TCP model or the OSI stack, it's very clear definition of each layer. But if I look at reality of what means IPv4 deployment today, this is the full scope of the deployment. So that's oh, by the way, you can look at what's about the application, and you got some demonstration how to run the application on top of v6. And you need to do something here to modify your application. At the same time, you need to look at what about the devices. Oh, by the way, yeah, we need to do packet filtering, ACL, QoS, multicast, and provide all feature routing protocol. But you also need to look at what I will call the infrastructure services, load balancer, firewall, IDS. So that means here, when we are planning the v6 integration, we need to look at the full pictures. And by the way, more important, how about education? How about operation? How do you train people? Like, for example, when you negotiate a contract with a third party, if you don't know, if the people who are negotiating the contract has no idea about v6, how can you make sure that the software they are writing for you can do v6? And the best example of what we are doing today, you can reach most of the time the Cisco.com website using IPv6. And we don't try to make any public advertisement about that. The main objective for us is to understand what do we need to modify on our portal to make sure we can support v6. And that means some of the URL are using relative URL, and you are safe. But some other are absolute URL, meaning you are using v4. So now we need to go to the subcontractor and say, oh, by the way, here, what you need to modify to make the application running on top of v6. So when you are considering the integration of v6, don't look at only one layer. You need to look at the full picture. Now, the fact is, as it was said, from an end user, I really don't care what you are using as protocol. I want to use my application and take access to it. So the tiebreaker is really the naming services. So that means here, DNS will return different kind of address. If you are using peer-to-peer protocol, you may be using the link local multicast naming resolution protocol, the peer naming resolution protocol, CORD or other, and that's how you will get your v6 address. Now, that means when you are running dual stack, like the Windows XP PC here, I can go and use Firefox and get a v4 or v6 address, and from there I will decide which protocol I will use to reach the application or to use the application. At the same time, when you are writing your application, you need to take care of different small items. Like, for example, let's say you want to put IPv6 on your IP phone. Remember, on your interface, you may have more than one IP address. That means now you have to display multiple addresses. From a GUI perspective, an IPv6 address is 128 bits, meaning it's taking more space. Look at the IP phone, for example, the screen. How do you display your IPv6 address? What about management? That means now from your network management application, you have to get all the addresses and make sure you can do the scanning for that. And by the way, when you are looking at your application, you have tools on the market, either on Microsoft or Linux or Solaris or any platform that allow you to go through the application through your code and see what's need to get modified. So now, when we are presenting v6 to customer, the main question we have for them is, oh, by the way, you have interest for v6 and you want to start now. But now the key question for you is between the business case identification and the day you will claim, oh, I'm now running V6 full production. And it could be a question for you at Google. It's how long does it take to go through all the steps? Doing a network assessment, meaning what do you need to modify on your equipment to make sure you can run V6? And from there, what will be the cost analysis? And where are you getting the budget for that? And then what's about training? What about project planning? Getting the address space, making the planning for the address, doing the test, the trial, starting to do the deployment, and claiming full production. So now if I look at the US mandate from the US Federal Agency, they say in August 2005, oh, all infrastructure should be ready in June 2008. But 3 years is really nothing to go through all the steps for such organization. So think about yourself. How long do you need to go through all the steps and make sure you can claim success? And that's the reason it's better to start now. Now, the fact is, one of the first steps for you is to get the address space. And from there, that means go to ARIN, register for your prefix, and I'm pretty sure it's already done. I have seen the Google IPv6 prefix. And you need to decide what will be the policy internally to allocate the address. But more important, right now, a lot of people are focusing on the upper 64 bits. But what about the lower 64 bits? One of the main differences between V4 and V6 is, if I look at V4, you have two ways to assign addresses. You can manually configure your address, or you can go for DHCP-V4. And you can do exactly the same for V6. But in addition of that, for V6, you also have what is called stateless auto-configuration. That means I can plug my video camera, just listen to the router advertisement, and get the prefix. Or on top of that, you also have privacy, meaning when I boot my Windows XP PC, I will get one address derived from the MAC address of my Ethernet adapter, but I will also generate a random number. So now think about tracking. Some of the people are still doing packet filtering based on /32 for V4. What about packet filtering on /128 when the address is changing every 24 hours by default? So once again, you need to understand all the mechanism and set the policy inside your organization to decide how you want to use that. Packet filtering. If you are familiar with V6, you may know that one of the main differences between V4 and V6, there is no option part of the main header. The main header for V6 has a fixed size. And that means when you have option, there are option headers. And some people will claim, oh, by the way, V6 will provide better performance because you can do V6 in hardware. It's a main header, it's a fixed size. But reality is, how do you parse all the option headers? When you do packet filtering, when you do QoS marking or remarking, what are you looking at as field? You are looking at source and destination address, and you are looking at TCP port number or UDP port number. That means now if you have option headers, you need to parse all the option headers. When some people say, oh, by the way, I can use IPsec, encryption NUR, ESP NUR for authentication. Remember that if I look at ESP NUR, the next header field to find the TCP or UDP port is at the end of the data payload. Now, does it mean you are parsing all the data just to find the TCP port number? No way. Or don't expect no impact on performance. So that's the reason here we need to do ACL in hardware. We need to be able to parse all the option headers, and that means looking at new generation of hardware with TCAM for that. And we have some white paper. Routing. Routing is not different between V4 and V6. And that's something important. Some people will claim, oh, by the way, V6 is solving all the internet problems. Not true. I mean, we are just using the same protocol for V6 as we are using for V4. It's 3PNG, OSPF-V3, ISIS, BGP4. So that means here, from a research standpoint, there is some good activity to be done. Now, if you look at the global routing table, it's around 800 prefix right now. Some registry are currently providing provider-independent space, which may not be the case in all regions. Like, for example, right now in Europe, the RIPE has not yet decided to allocate PI space. But what is more important, it's education. if I look at the current internet status for V6 today, there is still a lot of traffic going over tunnel. And that's creating a lot of trouble. I mean, you may be running one application like you want to do FTP, and from an end user, you don't know which version of the protocol you are using. And from time to time, you will be getting good performance, and from time to time, your performance may just sucks. And the problem now for the network operation is which version of IP are you using? So if we have discrepancy at the routing table layer, that will impact performance from an end user perspective. So that's something very important for education. You need to look at what kind of connectivity you are getting from your service provider. Now, when you are done with your planning, you can pick one of the deployment scenarios. And I really don't care which one you are using. When I look at all the customers we have deploying V6 today, the main objective for them is, one, provide the services. Second, at the lowest cost as possible. They want to control the cost of the deployment. So here, the way we are looking at the deployment, you can look at the core network. And basically, at the core network, you have two solutions. You are running a dual stack core, meaning you have V4 and V6, or we have people doing MPLS, and you can put V6 on top of MPLS. If you look at at the access layer, once again, you have two kinds of services. It can be a layer 2 access, and you can do dual stack. The only data link layer today, which doesn't support V6 natively, is DOCSIS before DOCSIS 3.0. You have to do tunnel for DOCSIS 2.0. How do you do that? Yeah, you do tunnel. No? OK, so let me know. And then when you look at layer 3, for people who are doing layer 3 services, you look at managed services. And that means here, the service provider must offer V6 services as well. And it must be ready for that. Now, if you look at your campus, you have two ways to do it. You can go for dual stack, doing V4 and V6, or you can do V6 over V4 tunnel, and it's what we call ISATAP. And by the way, you have transition mechanism like how to do V6 over V4 tunnel when you don't want to do native V6, or you can do translation as well, and this is where you can use NATPT. Now, the fact is, NATPT means you go from an IPv6-only device to an IPv4-only device. And if I look at the reality today, there is no single stack which are coming by default with V6 only or V4. I mean, for V4 only, sure, but not V6 only. If you want to do that, that means you have to turn off V4 by yourself. Couple of slides here. If you want to do V6 over MPLS, one of the key reasons we came out with the V6 over MPLS, which are now RFC number at the IETF, it's that people working on the MPLS or the service provider were looking at the core network and say, I don't want to touch the core network to do V6. At the same time, they say, oh, I need to provide V6 connectivity to the people on the edge. So the idea here was to use IBGP, make sure we were able to put label for V6 between 6P router. So what you can do here is just to configure the edge router, and now you can receive an IPv6 native packet from the input interface, do your lookup, put one label for the remote 6P, put another label for the next hop, and on the output interface, what you will put is an IPv6 packet with two labels. And the rest of the MPLS core network can transport the V6 traffic without any change. If you go for dual stack, what kind of services can you do as a service provider? And this is what most of the people are doing. You can do V6 for your, I would say, internal services. And I can look at what people like Entity or Free Telecom or other are doing. They put V6 on the CP device, on the set-top box, and they provide services for themselves, for their own customer. Or if you are a service provider, you can do peering. And I will say most of peering point today can do V6. You can do transit services, and we have good example of people doing transit services today, like Entity, Verio, and other. You can provide connectivity to the enterprise customer, and you can provide connectivity to the broadband user. And this is really where, if I look at the worldwide status, we are missing connectivity. There are really few service providers offering V6 today for broadband services. Security. One of the reasons we are recommending enterprise customers to start looking at V6 is for security. The reason is, as soon as you are getting a new laptop running Windows Vista, Mac OS 10, or Linux, v6 is on by default. And on any of these operating systems, you can do v6 over v4 tunnel. So that means on your firewall, if you don't know what kind of traffic go over protocol 41, you are opening your security. So the first recommendation we are making to our service, to our customer is at least you should be monitoring the v6 over v4 protocol and make sure that you can block it if it's not already done. That's the first recommendation. And from there, you can start using it. The second one is IPv6 is not identical to v4. So for some of the rules, like packet filtering, you need to understand the protocol, and you need to make sure that you will apply the right security rules for that. And it's true that if I look at the market implementation today, we are still missing features. Like IDS, for example, there is a big hole here in the market. Management. The other recommendation for management we are making is you can split management in 3 categories. The first one is you can do management over v6. But so what? I mean, remember that what you'll be managing is the dual stack network. You need to manage both v4 and v6. So the first recommendation, just to decrease the learning curve we are making, it's you can keep your management over v4, but what we need to provide instrumentation for the v6 traffic. And that means here we have to work on the MIBs, we need to work on NetFlow, we need to work on SLA, we need to work on all the instrumentation features you may want to use to understand what kind of traffic goes through your network. And then the third category is what about the management tools. That means you need to look at your product and make sure that your product can handle the v6 address, display the v6 address, and provide some capability like topology mapping, user tracking, and other. And you need to get support across all the elements if you really want to migrate everything to a native IPv6 network management. Now, what does it mean to go dual stack on a networking device? Remember that you will be sharing the resources of your device between both versions of the protocol, v4 and v6. That means here, if I look at the memory size, you will have the routing table for both v4 and v6, even though if the v6 table is small today. From a CPU standpoint, you are adding additional process, like what about OSPF v3, it's a new process. What about the address family for BGP or for ISIS? What about any application you are putting here for v6? And from a performance standpoint, I mean, if I look at the hardware forwarding or software forwarding, I don't care. Any platform today can achieve line rate for v6 or v4. But the reality, it's more about the control plane. Let's say, for example, you have fast convergence for v4, and you look at fast convergence for v6 routing protocol. Which one will converge first? And what will be the impact on your application? That's what you need to understand and what you need to evaluate when you are configuring your device with a dual stack approach. If I look at what we are doing at Cisco, just to provide some element, so we attach a Cisco network to the 6-bone in 1998. We have our own prefix registered to ARIN, it's /32. And what we are doing today, we don't provide v6 connectivity for any Cisco employee. We are really targeting the v6 connectivity for the engineering side, for the support organization, and for some people like myself or others who are testing the application. So what we have here, we have native IPv6 and tunneling deployed internally. It's really dependent of your location, where you are. We can do v6 over VPN. So that means the way we do it, we have the VPN client for v4, and we are using ISATAP as a tunneling mechanism. So that means here, even from the Google site, I can connect to a Cisco location, and I'm keeping my v6 connectivity from Cisco. And from there, we are also looking at how we can provide connectivity with the internet, and we need to peer with the service provider. So this is where we are right now. So just to conclude, the first one, from a market perspective, v6 is coming, but it will be a multi-year transition period. From a software developer, you should be IP agnostic. There is no reason today to write an application which doesn't work on both v4 and v6. From a network manager perspective, you need to make the upgrade, get trained, do the configuration. And from the end user perspective, who cares? I mean, you just want to use the application and services. Thank you for your time.